All right, good morning or good day, ladies and gentlemen. Happy Friday. Lesson I have for today, it's going to be a bit of a long one, but I'm going to talk about interest. This is going to be kind of wrapping up our finance unit. I'm going to have a small assignment based on this, where you're going to look at both simple and compound interest and solve some problems about both. We're not going to take too deep of a dive on this because we just don't have the time, but these are good ones to think about and know about and have in your brain for when you're thinking about, say, opening a bank account or taking out a credit card when you're older. So, first up, let's talk about interest and what it actually is. When you're dealing with banks, credit cards, or basically anything like most financial institutions that deal with money, they will pay you or charge you something called interest. The way we can think about interest, I like to think of it as like a lending fee. So if you put money into a bank, so if you're giving money to the bank, so I'll put cash into, I'll do a bank, then the bank will pay you to use your money. Because one of the things that we talked about with using paper money in those videos that I showed you, the bank doesn't just let it sit in the vault. They actually lend it out to other people. So at any one time, your money is probably not going to be in the bank, but if you want to go and take money out, you can. And you can, if you remember the video, you can see where the problem lies is if everyone tries to take out money at the same time, then the bank has some money borrowed out and we run into problems. But this is why they pay you interest. And it's usually a percentage of what you put in. So if you put in $1,000, they're going to pay you more interest than if you put $10 in, because it means that they have more money to work with. Likewise, if you're taking money from the bank, they're going to charge you interest. And this is how banks make profit. Because if they're lending out, say $100 and they get back 110, then they have $10 more to work with. So in any case, banks, credit cards, all these sort of institutions charge or pay interest. So if you're borrowing money, taking money from a bank, they're going to charge you interest, so it's going to be money that you're going to have to pay. And if you're saving money or investing it, the banks are going to pay you. Generally, they're not on the same percentages, but they work the same way. So the first thing I'm going to talk about is something called simple interest. And there's going to be some terms based around this. So interest money that is added to the principal. So our first variable is called P. This stands for our principal. And this is what you put into the account or borrowed. And they charge this based on some sort of percentage rate. So an example would be 4% or 10% or 0.5%. They're going to give you or charge you some interest rate based on what they've decided. Now, there's two types of interest rates. You can have a low interest rate or a high interest rate. So to kind of give this example, I have two stock images, one of a banker with a lot of money and one with a banker who's wearing oven mitts with a calculator that reads 0. So high interest rates, they are good for banks. If borrowing, bad for you. And they are good for you if you're saving, and then bad for banks, but I won't put that. So basically, if you're getting paid high interest rates, it's good. Or another way I can put it is good for so if you're putting money into a bank and saving it, you want the highest interest rate possible because the bank is going to pay you. If you're borrowing money, having a high interest rate is bad because it means you're going to have to pay back more. So conversely, having a low interest rate is good for whoever has to pay it. So for example, good if you're borrowing, bad if you're saving. The reason being, if you're saving it and you're getting paid the interest, you're not going to be getting that much. But if you're borrowing and you are the one that has to pay the interest, you want a low interest rate because you don't want to pay more than you have to. So that's kind of two ways to think about it. Now, how we calculate simple interest is through this formula. So there's two types of interest. Right now we're talking about simple, and it is given by this formula here, I equals P times R times T. So for each of these, I stands for our interest rate, P, this is our principal. Oh, I actually have the definitions down here. So I is the amount of interest earned over a period of time. Principal is the amount that you borrowed or the amount that you saved only. So if you put $10 into the account, your principal is going to be $10. R is our interest rate, and when we calculate it, we want to change the percent to a decimal. So like I was saying up here, they will give us a percent rate. We want to change that to a decimal for this calculation. Otherwise, our value will be too high. And the last thing is time in years. So a couple things for time. We can talk about things in different periods of time, so we're going to have to be aware of how many of each of these fits into a year. So let's think about days, weeks, and months. How many are in a year? So there's 12 in a year for months. Days, probably another pretty easy one. We have 365 per year. Weeks, this one might be tricky for us, but it's 52 weeks. So let's try an example, and I'll show you one method, and as well I have an alternative method for solving this. So, sorry about that. How much interest is paid over a 4-year period? I changed the question value just a little bit on $5,000 at an APR or an annual percentage rate of 3%. So the problem or the tricky part about this unit is that it gives us a lot of word problems. So we're looking for how much interest, a 4-year period, $5,000, and then it says an APR or a rate of 3%. So what I like to do for solving these is I want to set up on the side, I'm going to list out all my variables. So I have I have P, I have R, and I have T. And I'm going to try to figure out which one's which. So it says how much interest. So I'm thinking I for this one. Over a 4-year, it gives me something in years. I can immediately think time. On $5,000, I have to choose whether or not that this is my P or my R, but because it gave me a dollar sign, it's probably P. And then finally, rate 3%, so this is my R, but I have to remember it's 0.03. And where I get that from is I take 3% and I divide it by 100, which will give me 0.03. So how much interest? I actually don't know. That's what the question's asking me to solve. P is going to be my 5,000. R is 0.03. And time is 4. I leave them as numbers. I could put $sign over here, and I could put years. It's up to you. But when I'm doing calculations, I tend to leave the units out and deal with them at the end. So in this case, I have I is equal to P times R times T. So I'm going to substitute these in. So I have P is equal to 5,000. So I'm just going to put 5,000 here. R is 0.03. And finally, time is 4. So I put them in brackets. I can just as easily write 5,000 times 0.03 times 4. And this gives me a final interest of $600. So I've brought it back because interest is given in terms of dollars. So I'm going to remember my unit here. Now, one of the things to be aware of, this question shows us how much interest we've made, not what's in the account. To do that, we need a second equation. So I'm going to use letter A equals P plus I. So A, think amount. So when it says, how much is in your account? What's the amount in your account? It's whatever you started with plus the interest you've made. So A is equal to, in this case, we started at 5,000. And for interest, I have 600. So the final amount is 5,600. And again, it's in dollars. Now, this is one way to solve the question. However, this equation can be used in other ways, and we're not always going to be solving for the amount of interest. Maybe I know how much interest I've made, and I want to figure out how long I've had it in my account. So we can actually use this equation to solve for any other thing. I'm going to show two methods. One is sort of the algebra way. Since we're in grade 9, we're moving towards doing things a little bit more with mathematical rigor, I'll say. But I'm going to break this down the same way. I'm going to start with I is equal to P R T, or I'm going to figure out what the variables are. So this says to start, what principal at 4.75% will earn interest of $27.15 in 9 months? Oh, and I see time, but it's in months, so I have to be aware here. So 9 months, there's 12 in a year. So I have to think about what percentage or what fraction or what decimal this is. So if it was 6 months, it'd be easy, it'd be half. 9's a little bit harder. So I can do 9 divided by 12, and that's going to give me 0.75. And that's my new thing in years. So notice how up here I said there was 12 months in a year, and what I did was I divided by 12. If this gave you, say, like 300 days, what you could do is divide by 365, and that'll give you your answer in years. So time, I'm going to put a 0.75. R, 4.75, I'm going to move the decimal place over twice to the left. So I'm going to get 0.0475. And that's going to be my R. Principal, I have no idea. I is equal to $27.15. So my initial equation is I is equal to P times R times T. Or if I plug these in, $27.15 is equal to P times 0.0475 times 0.75. So what I can do, I notice that all of these are multiplying, so I'm going to divide both sides by this. I could just as easily figure them out first, but I'm also going to divide this side by. And so this side cancels out, so I'm left with P is equal to $27.15 over by the way, totally valid. to figure out what this is first and then just divide by the final number? Well, using BEDMAS, I'm going to figure out the bottom first and then divide the top from the bottom. So what I get for here, a final answer of $762.11. So that's me figuring out what the bottom is and dividing by the top. I'm just skipping that step for time. So my principal is equal to $762.11. Now, this might work for some of us. I'll show you a different way, and I like to call it Mr. Sproul's Finance Triforce Method. So here's a Triforce from Legend of Zelda, and I'm going to set it up a certain way. So I'm going to put I here, I'm going to put P here, I'm going to put R here, and I'm going to put T here. So how this is set up, and this actually makes a good foldable. If you were to make this triangle in your interactive notebook, it's a nice way of remembering all 4 equations to solve all 4 of these individually. So how do we use it? I know my initial equation was I is equal to P times R times T, or I'll just write PRT. So if I read this, I is on top and then P times R times T. So these vertical lines refer to multiplication. And what I'm going to say is this line here refers to division. Now there's an equal sign, so we need to come up with one more thing. So how you use this? Step 1, cover up what you want to solve. And make that on one side of the equals. So for example, I want to solve for I. I'm going to cover up my I, and I'm over here, I'm going to put I equals. 2 is whatever is left goes here. So whatever you read left, or whatever's left, so in this case I have P times R times T, I'm going to put here. So I is equal to P times R times T. Now that's for one that we already know. In the previous example, I was solving for principal. So I'm going to cover up the P and go P is equal to, well, now I have a slightly different equation. Whatever's left, I now have I divided by R times T, and it makes this sort of fraction. So I see I over R times T. And that's my new equation. And if I look back here, it says the same thing right here. This was my I, this was my R, and this was my T. So I've just rearranged it, but I've done it a different way. And this would actually work for each one. So for example, if I wanted to cover up R, R would be equal to I divided by P times T. And then last but not least, T would be equal to, so I cover it up, I divided by P times R. So that's a nice way of remembering 4 equations with a nice little triangle, so long as you remember how the triangle works. Okay, but this is generally not how things work in the real world. So I have an example to show you, and it's a cartoon, it's from Futurama, so I'm gonna skip to this clip. Basically, Fry has a couple, like a less than $1 in his bank account, and he wants to see what he has in his account when he travels to the future. So I'm gonna show you the example, and we'll try it out with a simple interest formula.
Crud. We're 50 cents short. I'd love to chip in, but Bender stole my wallet. Hey, that's my old bank. Maybe my account's still open.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $4.3 billion.
All right, so we've just learned about simple interest, and we just saw that Fry had somewhere in the realms of like $4.3 billion. So let's see if our simple interest formula works for this case. So if we take the numbers that are given to us, we are trying to calculate the interest or the amount in his account. So we're actually technically trying to solve for A, but we need to figure out what the interest is first. So maybe 1,000 years is a long time, but the principal, they said he had 93 cents in his account. The rate of his account was 2.25%, so 0.0225. And finally, the time was 1,000 years. So I is equal to 0.93 times 0.0225 times 1,000. I'm already seeing this probably isn't going to be that big. So at the end, it is equal to $20.93. So that's the interest. So, I can't forget, I have to add that $20.93 onto what he started with. So in total, he would have $21.86 in his account. So you kind of see the problem here. So why is Futurama telling us this? Maybe it's lying? Interestingly enough, it's actually telling us the truth. And here's why. When a bank pays you interest for the money that you're saving, it redeposits the money into your account. It doesn't cut you a check and then pay you. It puts it back into your account. So then for the following year when you earn interest, you have a new amount. It changes what you started with. This also happens when you're borrowing money. So the bank or credit card will make the amount your new debt. It'll put the interest onto your debt, and it'll be a little bit more that you owe. So say let's do this as an example to kind of show what's happening here. Say you invest $10,000 at a 1% interest rate over 3 years, but this time the bank reinvests or puts back whatever interest you made at the end of each year into your account. How much will be in the account after 3 years? So this is going to be year 1. I'm going to show it in a table, but each time we can think about this, 1 year has passed. So this is our year 1. We have year 2 here, and then year 3 here. And we can see what's going to happen, but where I'm going to start, I start with $10,000. The interest rate is 1%, so I have 1%, which converts to 0.01. And time is 1 year, so to get my interest, I'm going to multiply all these together, and I'm going to get an interest of $100. The amount in my account, so this is my A equals P plus I. So I'm going to add this to this. So at the end of the year, I'm going to have $10,000 or $10,100. Well, in year 2, that $100 is still in the account. So I'm going to take this amount and stick it here. And I'm going to get 0.01% interest because the rate hasn't changed. Again, it's going on for 1 year, and you can maybe already see, but this is going to give us a different number here, and it's going to be a little bit bigger. So I'm going to get a whopping $101. And then I add that to my amount that I have. So I'm going to get 10,201. I'm going to move this over into this table. Again, I have 1% interest over 1 year. So this is going to give me $102. And actually, they'll give me a cent as well. So now I end up with $10,303.01. But you can see in a simple interest case, if I just did I is equal to PRT and did T is equal to 3, my interest is going to be $300 because my principal hasn't changed. So in 3 years, I have earned $3.01 extra that I wouldn't have normally made. Now this doesn't seem like a big deal, but over time, it's going to get bigger and bigger and bigger and bigger. And this is how our second type of interest works, and it's called compound interest. However, there has to be a better way than just using a table. So I'm going to show you where we can get a formula from. So right now, it's time for some big brain math time. Don't worry, you don't have to memorize this. If you're keen on math, I'm going to show how we can get essentially the formula that you're going to see next. If you're not interested, you can kind of move ahead or just kind of zone out for a little bit, but take a look at where I'm going with this. So let's think about interest each year. And we have our interest formula, our simple interest formula is I equals PRT, and then I have this A equals P plus I. Well, if we think about it over the span of 1 year, or 1 year at a time, then T is equal to 1, so then I becomes P times R times 1, or I can just say P times R. So I'm going to use I is equal to PR with the express idea that I'm staying at 1 year at a time. So I have year 1, and I'm going to think about how much is in my account. So A is equal to my principal plus my interest. But I have just said, and I'll put this little 1 to show that it's year 1. Well, I've just said that I is equal to P times R. So another way I can write this, I'm going to change the I for this. So I'm going to get I is equal to P plus P times R. And we'll actually learn about how we can do this, but I can rewrite this equation as this. Because I have P multiplying both things, it's sort of a common factor, so I can pull it out and just say like, hey, this is going to be multiplying the 1 and it's going to be multiplying the R. So it's in both, but I'm going to simplify the answer to look like this. And so after 1 year, I'm going to have this. And then because it's compound for year 2, I'm going to reinvest. So whatever my A1 is going to be what goes into my new account. Or I'll put it another way. Now I have A2 is equal to P2 1 plus R. All I've done here is I've just used this same equation for my second year, and I've just said that whatever my principal at my second year is, or at the end of the first year, is P2, and I'm going to calculate the amount at the end of year 2. What's important for us is that P2, the amount that I put in at the beginning of the second year, is equal to what was the amount in the first year. So I can rewrite this as A1, or A2 is equal to A1 times 1 plus R. Well, A1 is this. So A2 is really equal to P times 1 plus R. So that's my A1 times 1 plus R. And simplifying this down, I get P. 1 plus r times 1 plus r, I can rewrite as 1 plus r squared. Okay, well, year 3, I'm going to start the same way. A3 is equal to P3, 1 plus r. But now I have P3 is equal to A2. What I had the year before is going to go here just like before. So now I'm going to have A3 is equal to A2, 1 plus r, which if I just take this final amount is equal to P 1 plus r squared times 1 plus r. Using the power rules we just learned, this is going to be 1 plus r cubed. So A3 is equal to P 1 plus r cubed. Couple things to be aware of. The P is our original value, and this 3 and this 3 are the same. So I can expand this out and keep going, and I end up with a to the n is equal to P times 1 plus r to the n. If you had trouble following that, that's okay. I'm going to modify this equation, but this is basically our compound interest formula. If we put something in for 1,000 years, we're going to take whatever this is to the power of 1,000 and then multiply it by our principal. So it's going to get bigger and bigger and bigger and bigger over time, and our money's going to grow and grow and grow. So compound interest, as you've probably noticed, it's much more complicated. You build an O interest on both the principal and the interest. Simple interest was just on the principal, but now compound interest also includes the previous interest earned. If you're saving, it's a good thing. If you are borrowing money, it is terrible. And the thing is, basically every bank, every financial institution, every credit card will charge and give interest based on compound interest. So our new formula has some new numbers in it, or some new letters, I should say. But the equation, you'll see it's fairly similar. There's this P times 1 plus R, and then there's a power. We've included, or we've added the letter N, and we have this number T. So things that are the same. A, final amount earned, so this is our interest and our principal. Principal is the initial amount of money that you put in, so what you started with. R is the yearly percentage rate as a decimal, so far these are the same as simple interest. Same thing with time. Time is time, or T is time in the number of years, and then N is this idea of compounding. So how many times do we pay the interest and then put it back in the account? Because that's going to be important. Does it happen at the end of the year? Does it happen at the end of the month? Does it happen at the end of every day? So we have this letter N. So what you need to know, if we are compounding once a year, our N is equal to 1, because it happens at the end of the year. If it happens quarterly, or if it's compounded quarterly, think about chopping the year into quarters. So there's 4 quarters, so there's N is equal to 4. Monthly, there's now 12 months, so at the end of every month, it's going to get compounded, so N is going to be equal to 12, and daily, N is equal to 365. So let's try this out. So now I have A, I have P, I have R, I have T, and I have N. I no longer have an I don't really need to worry about it because now I'm figuring out what's the total amount in my account from the start. So in this case, find the, oh, they're actually making it a little bit difficult. So find the interest earned, so I actually have to find this. If $6,500 is deposited in the account paying 6% compounded monthly for 5 years. So 6,500, this is my principal, This is my rate, so it's equal to 0.06. Compounded monthly, so this is my n is equal to 12. In 5 years, this is my t. So 12, 5, 0.06, and 6,500. I don't know what my a is, and I don't know what my I is, but I'm going to start with a is equal to p, 1 plus r over n, and t. And I always like writing out the equation, just so I have an idea. So a is equal to 6,500, 1 plus 0.06 over 12, and I have 12 times 5. So what I would do first, use bed mass or bird mass. So I am going to do that first. So I get this is equal to 6,500 times 1.0225. Almost 1. Up here, my second part, I take 12 times 5, so I get 60. So I've done each of those separately. Now remember about power rules and brackets? This part here is to the power 60. The 6,500 is just multiplying it. So again, following bed mass, I'm going to do this part next. So 6,500 is going to stay out here, times, this is going to give me a number of, it's not that big, but let me just calculate it real quick because I seemingly forgot. So for here, you're actually going to need a scientific calculator is one of the things I should say, because most regular calculators, you don't want to be multiplying this by itself 60 times. So I get a value of, no, I actually got a way too high of a value. Sorry, I have a typo here. This is 0.005. Okay, so this gives me 1.3488 ... Multiplying it to 6,500 gives me a value or a final amount of $8,767.53. And I'm always going to round this one off to 2 decimal places. So last but not least, it asked for the interest. So I started at 6,500, I end up here. So my interest is equal to 8,767.53 minus 6,500, and that gives me a final value of my interest is $2,267.53. By the way, if you were to use the simple interest formula, so I'll put your A would be equal to 8,450. So keep that in mind, that between these two, roughly $300 more from compounding. And we haven't changed anything else. We just said it was compounded. So $300 more from compounding with the same interest rate over the same period of time. It's always going to result in a bigger number. And this is how the world works. So let's try this Futurama problem again, but now with what we know about compound interest and see what we get. So we're trying to solve for A, the amount, P, the principal, is our 93 cents. Rate, 2.25%. So 0.0225. Time, we now have 1,000 years, and we don't know what the compounding period is, but we're just going to say it's equal to 1. So I have A is equal to P 1 plus R over N to the power of N times T. So 93 cents, 1 plus 0.0225 over 1 to the power of 1 times 1,000. So this is pretty straightforward. Dividing things by 1 just makes them themselves. So this will be 1.0225 to the power of 1,000. But this leads to a huge number. So when I take this to the power of 1,000, it becomes in the billions. So in total, plugging these in, I now get 4,283,508,000, or 508,000, sorry, $449.71. And if you remember, in the video they said
That comes to $4.3 billion.
so. In reality, it's pretty darn close. So Futurama was telling the truth. Now, in reality, a couple things to watch out for. If we're generally not going to be investing things for 1,000 years, so this number here should be very close to 1 when you take it to a large power. Otherwise, it's going to get really, really big. When I had 1.0225, like I pulled this number from the example, it was giving me 3. So then when I was multiplying, I was getting 18 or 19,000. It wasn't working out. So try to think about how much you're putting into an account and getting out. If for whatever reason your calculator spits back a really big number and you're like, hey, I'm investing like $20 over the span of 10 years, and it's saying I've made $20 billion, you've probably missed a 0 or a 1 somewhere or added something wrong, because we're dealing with real money, so it should reflect that. So one of the things to be aware of is try and make sure you're doing things in the proper order, or else your answers are going to not make logical sense. And the questions I'm going to be asking are going to should make logical sense in terms of a real world question. Okay, that's all I have for today. What you're going to need this for, our homework, I've made a mini assignment that I'll be posting today. And it's going to be due Wednesday. So next Wednesday. That way you have the weekend to work on it, and you have some days that you can ask questions on the discussion channels, but you're going to be using the 3 formulas that we've learned. So you're going to be using this A equals, so the compound interest formula, and you're going to be using the other 2 that we talked about up here. So our simple interest formula with the triangle, as well as the A is equal to P plus I. And the main goal is that you're able to figure out what the questions are asking and break down the problems. So on Monday, I'm actually going to show a video on how to break down word problems. If you're having a difficulty, I highly recommend you watch it. It's something that you can put into your interactive notebook. And as always, take care, stay safe, have a good one. Bye.